Hey, this is James TCon, and today we're going to try and create a dynamic character controller with Bullet. Now, there's another type of character controller you can make that's called kinematic character controller, and I might take a look at that in a future video. But for now, we're going to start with dynamic, because dynamic character controllers are easier to set up usually, but they're more difficult to have precise control over the character. When you would want to use a dynamic character controller is if you're trying to control something like a vehicle or a boat or a spaceship, something like that. They work great because you're controlling a dynamic rigid body. That rigid body is affected by gravity. It's affected by other objects that can bounce into it. So if you have a spaceship and you crash into another ship, with a dynamic controller, that ship can get pushed around. And they have things like, you have inertia and forces that apply. So depending on how you set it up, you could let go of the forward key and you could have the character keep sliding for a while, which is something great for like a spaceship or a boat, because something like that, it doesn't stop immediately. It'll keep moving for a bit with the inertia. And so we'll start off with that, and what you see in this demo is what we're going to try to achieve. And with that, I will say that character controllers are one of the very difficult things to set up and get right in Bullet. And what you'll have here, what we're doing here is not going to be a production game ready controller. It's just something to get you started, because there are so many different ways, depending on what kind of game you're making, there's so many different ways you might want that controller to behave. The only assumptions I'm going to make here is that we want to be able to move around, turn, and jump, and hopefully be able to get up some ramps. Things like stairs are traditionally always a really difficult thing to handle in a controller, and what we're going to be doing here, you can jump up the stairs, but nothing too crazy in this one. So now that you see what we're going to work on, let's go ahead and get started. Before we get started adding new code, I want to talk about some changes that I've already gone ahead and made to save us some time, because they're not all of them Bullet related specifically, more just for the project. I've done some cleanup on the base screen. The base screen now has this abstract class, the camera controller, so that we can switch to different types of camera controllers for my different for the different demos in this project. So it just has this abstract class and defaults to this first-person camera controller. So that first-person camera controller is pretty much a direct copy of the one built into libGDX already, except it extends from that base class now, or that abstract class. Also, I've moved the create objects method from our rigid body dynamics video into the base screen, so I can reuse it for other screens like the one we're working on today. This Bullet entity is just a new class that holds a reference to a rigid body in the model instance, just to keep them together. It's going to be helpful for the character controller. And the camera controller, that's the abstract class. All it does is add an update method, and it extends input adapter. And so we have this dynamic character screen. This is our new screen that we're going to be working on for this tutorial. Pretty empty right now, just setting the camera position, and that's about it. This is where we're going to be working a lot today. The first person camera controller, as I mentioned, it's pretty much a straight copy of the one from libGDX, except I extended the camera controller abstract class. Rigid body, that's from one of our previous videos. I had to do a little cleanup there, nothing to mention here. The select screen now adds an option for this new screen we're working on today, the dynamic screen. Third person camera controller is a new camera controller that I've built, which we'll be using to follow the character. I won't really be talking much about this. It's very basic. It just follows behind the character. I've added some comments in here if you want to understand it, but I'm trying to focus on Bullet today, so we'll be talking about that. And then I have this utility class that just has some simple methods, a method to get a direction of the model, get the position of the model, and this method which is going to build our little character that you saw. We're going to actually build the character within the code. I try to comment this a little bit if you're curious, but again, we're talking about Bullet today, so we're not really going into that code too much. Okay, now to actually get started, I'm just going to do a quick run of our project to see what we have right now. And if I go to our dynamic character screen, it's just the floor with the objects falling on it, nothing else going on yet here. And so now we'll get started on this dynamic character screen. And so I've gotten some feedback on previous videos to increase the font size in IntelliJ, so I've done that. I've increased the code font size as well as the UI font size. I try to make it larger while also not driving me crazy, because a big font, it's easy for me to get lost in the code. So hopefully this is helpful, makes it a little bit easier to see things. Let me know. Now to get started, we're going to go ahead and up here where we create objects, we have that bullet entity class that I showed earlier. And that's going to hold a reference to our character's rigid body and the character's model. So I'm just going to go ahead and add this bullet entity player equals, and we'll do this create player method here. And let's go ahead and Alt Enter to create that method. And if we scroll down here, okay, we're going to get the model instance of the character. We'll just say player model instance equals a new model instance here. And so I've got that utils 3D class, and I'm going to do this build capsule character. Like I said, if you can look at the code if you want to. I'm just not going too far into it today because all we need is a model to move around. You could use a cube if you wanted to. So we're going to write some code to, I'm going to actually transition him up slightly above the ground. So we'll get that model instance, transform it, and I'll just set to translation here. And let's do, actually, we can just do, we don't have to do a vector 3. 040, we're just moving them up a little bit. And now, so what we need to do is calculate our dimensions. So we're going to use a capsule shape for our character, because you saw before, it's kind of like a capsule shaped character here. And to do that, so we're going to need to get the bounding box from the model instance. So we'll create a new bounding box here, and we can go calculate bounding box on the model instance and pass in that box instance here. And then we'll get a vector 3, call it dimensions. And then we'll call bounding box get dimensions, and that's going to give us basically our dimensions of the model, which we can now use to build our capsule shape. And the way Bullet works is it uses these half extents. So I have to scale the dimensions by half. And then we have our motion state from our rigid body physics video. So we'll create a new motion state, and that takes in the model instances transform. And now we're going to create our bullet capsule shape, and that's called BT capsule shape. And what we're going to pass in, so this takes in the radius and the height. I'm going to take the capsule shape here. So I'm going to take the dimensions, the length or magnitude of those dimensions. And I'm going to divide it by 2.5. You can divide it by 2. I found it looked, because the model has some arms and things that stick out as well, it's not a perfect capsule shape. I divide it by 2.5 instead. 2 is if you just have a capsule with nothing else. And generally you could just divide by 2 here. But just, I already know ahead of time that the model has some arms sticking out, so that's going to cover that for us. We're also going to define a mass value here. And since all the objects that I create, all those random objects that we're going to create and fall on the floor, I think they have a mass of 1. So I'm just going to give the model a mass of 2 to make it a little easier to push those things around. We'll create our inertia vector here. And so for that, we do the capsule shape, calculate local inertia. This shouldn't really be new to you if you've watched the previous videos. And that's why I'm kind of going through these quickly here. And then now we're going to create the rigid body. So what we need to do is get the rigid body construction info first. And that takes in the mass, our motion state, the collision shape, and the local inertia. And now we can instantiate the rigid body. And that just takes the construction info. Okay. There's going to be some other changes we'll make, but let's see how far we can get with this. So one other thing we're going to want to add right now is the activation state on the rigid body. So we go body.set activation state and collision.disable this deactivation. So that'll prevent the model, or not the model, but that'll prevent the physics body from going to sleep, which we've seen on the debug drawer video. If a rigid body is not moving and it's kind of just stagnant, just sitting there, the full physics engine bullet, it puts them to sleep for performance reasons. And what we do here is, because this is going to be a character's physics body, we don't ever want it to go to sleep. We want it to always be active. So what we do is we set activation state. If you don't do that, probably after 30 seconds or so, you're just not going to be able to move anymore because your rigid body went to sleep. And now, so we've got that render instances array in the base screen. We're going to add our model instance to that so that it's getting rendered. And then we'll call our bullet physics system and add the rigid body to the physics system. And lastly, we're going to return that bullet entity. And so that constructor takes in a body in the model instance. Here we go. And let's scroll up here. So we got this player object. Taking a look real quick here. So we don't have a character controller yet. Let's see. Let's just see what happens when I run this. I think we should see the character in the world. There he is. And you can see he gets knocked over, right? We're not controlling him or anything like that yet. So the next thing we want to do is a couple more changes to the body inside of the create player method that we just created. So let's go down to where we set that activation state. And you saw how the character, he kind of just flopped over. Obviously, we don't want that. We want the character to stay upright. So if we go body.set angular factor and we set vector3.y, that should keep the body, the rigid body, from being able to fall over. Let's just test that real quick. Yeah, see, now that cube landed right on his head and he didn't fall over. So that's what that angular factor is doing for us here. Okay, so now we're going to get into the fun stuff and start creating our dynamic character controller class that's going to hold all of our, movement logic. And to do that, I got this controllers .camera package that has our camera controllers. Let's try to create another package here. Back it up into this controllers character. We'll do that here. And then inside this character package, we'll create a new Java class and call that dynamic character controller. Okay. And then so for the constructor, we're going to have a couple arguments here. Let's see, let me hit Alt Enter, constructor, and I'm going to add a bullet. It's going to take in the bullet entity. And that'll be that bullet entity we got with the create player method. And it's also going to take in our physics system. And so then we're going to store a reference to some of these things here. So we'll have a private final bullet entity character and a private final bullet physics system. Just call that physics system. And we'll set them here. So this dot character equals entity and physics system equals bullet physics system. Actually, since they have different names, we don't have to use this keyword. And we're going to add a update method here. So let's go public void update, which takes in our delta time. And so we have an instance of our character. We have the bullet entity already. So we call this utils 3D class and get direction. This takes in the model instances transform object. So on our entity, we can get the model instance, get the transform. And it also takes in a vector out. And what that means is we're gonna keep track of the vector in this class. It'll be held in this class. In this utility method, you pass in the vector, and it doesn't return anything. What it does instead, see, it returns void, but it's going to populate this out vector with the direction. And that's usually the easiest way to do it. If you try to have these utility methods return a vector, things can get messy very quickly. It's better for, in my opinion, the way I like to do things is whatever class is using that vector, that class owns that vector, or vector 3 in this case. So we'll call that current direction, and I'm going to put that up here. So we have this private final vector 3 current direction, and we're going to pass that in to this utility instance, and that's going to give us a direction. Now, the way that this get direction is working, it assumes that the forward vector of your model, the forward direction of your model, is z. If your model is rotated a different way, if it's x, then it's going to be off by 90 degrees. But I think from my experience, most models are z forward. And so it just takes this temporary vector, sets it to a vector 3z, and then it rotates it by the model transform, normalizes it, and then it sets our out vector to that. And that's going to give us the current direction of the model. So an easy 2-line way to get the current direction of your model. I know it took me a while to figure this one out when I first started. So hopefully that's helpful for you. So we're going to call this, we'll get the direction of our model. And now we can go, let's get the rigid body from the character, from the bullet entity. Get body, there we go. And I'm going to create a method here called reset. Actually, we're gonna want to do that. Let's do this first. Let's keep it simple. Let's just start with the inputs. We'll start with that. So we'll say if the W key is pressed, we're gonna need another vector here, which is gonna track our linear velocity, and we're actually gonna need one for angular velocity too, so our turning. I'm gonna just bring those over from my sample project here. So what we have is a vector 3 linear velocity. That'll be our forward and backward movement. Angular velocity is going to be our turning rotation. And so let's come down back to this input polling that we have, and we'll use this linear velocity, and we'll call set and set the current direction, and then we're going to scale it by our delta time times a move speed. And so just to keep things very clear, and I keep forgetting to move this down, sorry about that. Let's close that window. We'll want to define some kind of move speed up here just to keep things consistent. So we could go private. It doesn't have to be a final if you plan on like having a variable move speed or whatever. But for now, we'll just go move speed, and let's see. I used 10F for the demo, so we'll stick with that. So let's copy this, move it down here. Okay, so this linear velocity vector is going to be, we're going to set the current direction of the model based on that, and then we're going to scale it by our move speed, and that's just going to create this velocity vector for us, which we'll be using on our rigid body. And so let's just do the inverse of that now, which is our rear movement. Else if is key pressed. I'm just going with a WASD. Linear velocity dot set. Pretty much the exact same line actually. So I just copy and paste that, except we're just put a minus sign in front of the delta to invert or make this vector now negative, so it'll be in the opposite direction. Let's do our turning here. So we'll go, I'm just going to copy paste some of this to make it a little bit easier. And add some comments while we're going here. Forward movement. Turning. And so now this will be our A and D keys. And instead of linear velocity, we'll be setting the angular velocity. So let me back that out and call angular velocity dot set, and we're rotating on the y-axis. So we put 1 for now. If you have different rotation speed, you can change this just similar to what we did up here. You could do delta times it. I just do 1 or -1, but again, you can change this as need be. And if you didn't already guess, all we have to do is do -1 for the opposite direction to turn in, or rotate in the opposite direction. And now what we got to do is reset this linear and angular velocity every frame. Now you notice that I'm not creating, I'm not going vector3 equals new vector3 every update frame, right? You don't want to instantiate vector3s over and over and over again. Instead, reuse them. Now, to reuse these properly, we need to reset them after each, or before we start using them again, we need to reset them back to 0. So I'm going to create this reset velocity method. And in that method, all I'm going to do is reset our angular and linear velocities back to 0. Now, if you had a ship or something like that, your behavior might be different. But for something where we want the character to almost kind of almost completely stop moving, we're just going to zero these out every frame. If we didn't zero these out, then your velocities are going to stay the same and just keep getting higher and higher, or keep adding on to them. And your character is going to go super fast. It's just going to keep sliding forever, essentially. So that's why we have to zero these out before we reuse them again. Otherwise, say you don't do any movements in this update, but your linear or angular velocity are still the previous value from when you last moved, and that's why we're doing that. Okay, so now we need to apply this linear and angular velocity to the body. And to do that, what we can check is if the angular velocity is not 0. And let's do the same thing up here. If the linear velocity is not 0. So for linear velocity, we'll call the body.apply central impulse. So again, we are not setting the transform ourselves. We are pushing the character in the direction we want him to go. If something hits him, he may not go in that direction, but this is the direction we want him to go. And so that's now going to apply our linear velocity. And now for angular, this is called set angular velocity. And we just pass in our angular velocity vector there. Okay, so now we're going to try to use the character controller as it is. It still needs some more updating, but let's just see what we have now. Make sure it's at least kind of working. And so we go back to our dynamic character screen, and the character screen is going to have a reference to a dynamic controller instance. So if you go down into our constructor and go down below where we create that bullet player entity, we'll instantiate the controller here. Controller equals new dynamic character controller. And we pass in the player bullet entity in this bullet physics system. And then we need to override the render loop from base screen and update the character controller. So we'll just update that every frame. And then make sure to keep calling the super here so that everything is getting rendered. And now if we try to run that, let's see what we have here. So if I press the forward key, he's moving. And if I press the turn keys, so I press right and I let go, he keeps rotating forever. If I press left, let go, I'm not holding it anymore, he's still turning. And then we can also see when I press the forward key, he's kind of like he's sliding on ice. So I'm going to press it and let go, and he just keeps sliding for a while like he's on ice here. So we'll take a look. We can fix that. This could work for something like a boat or a ship, something like that. But for like a humanoid kind of character, it's not going to work for us. So to fix those two things, we head back to our create player method. And down here, there's a lot of different ways that you can configure these rigid bodies. What we're going to need this time is this damping. And, you know, in the documentation, unfortunately, there was nothing about damping in Bullet, but from what in the Bullet SDK manual, but from what I understand, damping is kind of like friction, but it doesn't require the object to be touching something else. So in Bullet, you can set friction values as well on bodies, and depending on what you're trying to do, friction may be what you want. So you can set a friction value. But for this case, we want the damping to apply regardless of if he's on the ground, if he's not on the ground, if he's colliding with something, if he's not. And that's what damping is going to do. It's kind of like friction, but it doesn't need to be colliding with another body. But it's going to kind of slow things down for us, almost like apply a counter force for our forward velocity and in our turning as well. And so the values that I used in a demo that worked well for me is, first we have this linear damping, and that's going to be our forward and backwards movement. Now I want him to still not come to a complete abrupt stop when you let go, but maybe just slide for a little bit and then come to a stop. So I put it at 0.75. Now for the angular dampening, I'm going to put it all the way at 99. And that's because we're turning it, you know, you want the turn to, you know, I press the A key, he turns, let go, I want him to stop turning right then and there. There might be just a little bit of a slide, but not much. And again, you know, you tweak this to however you want it to be. Now if we try to play it again, let's see what we have. Okay, so I'll press W, and now I'm going to let go of the W key. And he comes to stop very quickly, but smoothly, rather than just immediately stopping. It's kind of like a nice little smooth stop there. And I press the A and D keys, and the rotation looks pretty good. You can see I'm going to let go. He just slides for like a hair, and then he stops turning. There's many ways to do this. You can use friction. In this case, I'm just using the damping values instead. So now we have the basic character moving around, and I can push things around. It's pretty cool. Now, next we're going to try to load in a little more of a kind of scene, like a model that we can walk around on. You know, this is just a flat surface. So if you remember in the demo, there was like a slope, a ramp that you could climb up, and stairs. We're going to load that in next so that we can test him out on different surfaces rather than just a flat surface. For the little test model, that's like our kind of walking test area. I actually got this OBJ file from the libGDX tests. I resized it a little bit in Blender, brought it into Blender, made it a little bit larger, and now I brought it in here. If you want to, if you're coding along and you need the file, you can pull down this this repository, the Bullet repository, and get the file from there. And that's what we're going to use for testing, kind of like our test area, you know, to see can he climb up the ramp and things like that. So now that we have this OBJ file, we want to load it in on our dynamic character screen. To do that, let's go to our constructor here, and we'll do it down below. Load a walkable area, and we're going to get this. We'll just call it the scene model. And I have that utils 3D class. I just got a utility method there to, or is it not there? Let's check a look here. Utils 3D. It's not in there, so I'm going to add a quick utility method for loading an object or OBJ file. I'm just going to paste it right in here. Nothing crazy here. It creates a new instance of an object loader, or I keep saying object, an OBJ loader, and loads that and returns the model from after it loads. So now if I head back to character screen, we can call that load OBJ, and I put it in the let's actually create a new directory under assets and call it models, and I'm going to move that OBJ file in there. Here we go. And so now I can just go, let's see, this is going to take, what is it going to take here? Yeah, we need to do a GDX files internal, because it's that assets directory. And we just go models / scene.obj. And now we'll create a model instance from that model. We'll call that scene instance. New model instance. And pass in the scene model. And now I already know that this scene model, because I had it in Blender, it has 4 different materials on it. So I'm just going to paste this real quick. All I'm doing is getting the materials. There's 4 of them. I'm getting the materials off of this model instance. And I'm setting them to different colors just so that it's easier to, easier to view the scene. Because if it's all the same color, everything blends in. It's really hard to tell what's going on. So now I'm going to go render instances dot add. We'll add that model instance to our render array. We still need to add it to the physics world now. So we'll do this BT collision shape equals bullet dot obtain static node shape. And this is a very handy method. If you have a model instance that's static, it's not going to move around. It's your ground. There's this convenience method, static method here, obtain static node shape. All you do is pass in the nodes of your model instance, and it's going to return a shape. I think it does one of 2 things. If I recall, I'm going off of memory here. I think it either returns a triangle mesh shape, or it returns a compound shape. One of the 2, but it handles the building of the shape for you, and it works pretty well for static objects. Now, so let's keep going here. We're going to have to create a rigid body, construction info, scene info equals new construction. It's going to be static, so it's going to have 0 mass, null for the motion state. Pass in our shape, and vector3 0 for this, since it's a static object, for the inertia. Okay, now we instantiate the rigid body. Pass in the info. And bullet physics system, add the body to it. All right, now with this, now that we're loading in this scene, I'm going to remove this create floor call. Let's see if, what happens if we try to run this. Perfect. So now, now we have this test world we can use to kind of walk around and test out our character controller. So now let's hook up the third-person camera controller to our character so that it follows him around the world. And what we'll need to do is, after we have this, the create player method, after we've done that, we can call this method set camera controller, which is a new method in the base screen. And it just sets the camera controller that you pass into the current controller, and also sets it as the input processor. So if we come back here, we'll set camera controller to a new third-person camera controller, pass in the camera and the follow target, which is going to be the players.bullet entity, get model instance. And we also need to now remove this line because that's going to then, this will end up nulling out our third-person camera controller. So remove this. And if we try to run it now, the controller should kind of follow the player around a bit. There we go. So perfect. It follows him around, and I can, scroll a little bit, scroll forward, scroll backwards. See, he has some eyes there. Scroll back. So this is great. Very simple character or camera controller, just for for testing purposes here. So now we're going to try to implement some jumping logic. To do that, in our dynamic character controller in the update method, after our forward and turning logic, we can put in this check here for the space bar. For that's what I'm using in this demo. And there's one other thing. We're checking if the input is key just pressed, which is different than is key pressed here. So is key just pressed, space bar. Then we're going to modify the linear velocity and the y values specifically. Well, plus equal whatever our jump amount or force that we want for the jump to be. And we can put that up here. along with move speed, so we'll call it a jump factor. And I think I used 15 for the demo, so we'll paste that there. Linear velocity y plus equals the jump factor. Okay, and then that's going to get applied on the next line. Now if we play this, we should be able to jump. I think we'll see an issue that's going to need to be fixed, but let me show you that. So I can jump. This looks good. Great. The only problem is I can keep jumping by just pressing the space key. I can just keep jumping forever. And you know, hey, maybe your game, you know, maybe you want to implement a double jump or something like that, then that's great. But let's say you don't want that. You want to be able to jump once and not be able to jump again while the character is in the air. And to do that, there's a couple different ways. What we need to essentially do is check, how do we, you know, are we on the ground or not? How do we check if we're falling or if we are currently on the ground? The way that we're going to do that is using raycasting. And if you're not familiar with raycasting, you'll want to watch, I think it was the previous video actually that I did, is on raycasting to explain that a little better. Because I'm not going to be explaining it so much here, as just implementing it, showing you how to implement it. Now what we're going to do in this case to check if we are on the ground or not is we're going to cast a ray from the object, from the model's or character's position, which in bullet is going to be the center of this capsule. And we're going to cast the ray directly down below, underneath the capsule. So it's going to start from the capsule and go down. And we're going to look for the first object that we can find, if any. If we find an object, and now we only want that ray to go a little bit below the character's height. So if we find that the ray collides with something, then we know that he's grounded. He's on top of something because the raycast found something right below the character. If the raycast doesn't find anything underneath the character, then we can safely say that he's not on the ground because, well, there's nothing underneath him at all. He's not standing on anything. And that's what we're going to do now to detect is he grounded or not. To check if the character is grounded or not, in our dynamic character controller, we'll set up a boolean up here at the top. Boolean is on ground equals is grounded, and that'll be a new method that we're going to create. I'll hit Alt Enter and create method is grounded. And we're going to need a couple things that should be familiar to you from the raycasting video. I'm just going to bring them over here. And what we're going to use is a ray result callback. And in this case, it's going to be the closest, not me, ray result callback, because we don't want this ray to collide with the character controller's body. We want to see what's beneath the character controller, not without detecting the character controller's body when we do this raycast. So we're going to need to instantiate this callback. We can do that here in our constructor up here. So say callback equals new, and let's take a look at that constructor. So it takes the collision object that you don't want to be included in the collision in the raycast detection. And so that's going to be our character.getBody from that bullet entity class. We just passed that into the callback, and now the ray will never intersect with the character's body. It'll ignore it. And so now we want to go down to this isGrounded method here, and we got to actually implement this raycast. First, what we're going to do is reset our callback object, because we're going to keep reusing the same callback. To do that, we can set closest hit fraction to 1, and set the collision object to null. And we're going to have this, we want to get the position of the character. So let's go utils 3D. I have that get position convenience method here, and we're going to pass in the character, so the bullet entity, get the model instance, get the transform of the model instance, and we're going to need a vector 3 to hold that position value. Let's see, so we don't have one yet. Let me bring one in. So there we go, private final vector 3 position. pass that in. And this is just super simple. I mean, it's not necessary. I just have it for clarity's sake. It just takes the transform of the model instance, calls get translation, sets it on the vector. The convenience is just there to make the code a little bit easier to read. Okay, so we're going to get the position of the character, and I'm going to need another vector 3. I'll just call this temporary position. I'll put it right below here. So another vector 3 temp position. And so enter is grounded method. Let's go temp position. Oops. Dot set. I'm going to set it to the player's current position, but I'm going to subtract it by a small amount on the Y on the vertical axis, which is our Y. 1.4 is what I'm going to start with, and I'll explain why. So, the position is going to be where the ray is going to start from, our character's position. This temp position is going to represent the endpoint of the ray, where the ray is going to shoot to. And so what we're doing is we're setting it to the starting position, the same position of the character, but then subtracting a small amount on the vertical axis on our y-axis, so that the ray is going to be at the same position as the player, but just down a little bit. That's going to be the end position of the ray where we're going to shoot to. And this 1.4, the reason why I've chosen this value is in the capsule character, this utility method that creates our character. If we take a look here, when we create the capsule body, the height of that body is 2f, 2 for a float. And that means that with bullet, of course, we're casting from the center. This position value is going to be the center of that capsule. If I do just 1, of course, that's just going to go right to the bottom of the capsule and no further. So it needs to be a little bit more than half of the capsule's, half the capsule's height, right? So if your model's is a value of 2 for the height, then you need to cast 1 and a little bit over that, because we're starting from the center of the model. So half of your model's height plus a little bit more is going to get us just below the model. So that's the purpose of this line here. And let me bring a comment in here from my demo project. Just to explain that a little better. And now we've got this physics systems raycast method. We're going to pass in the character's current position as the starting position for the raycast. The to position is going to be our temporary position. And then we're going to pass in our callback object. And lastly, return callback dot has hit. So we're just going to return, did we hit something other than the player or not? And if we come back up here, so now we've got that grounded check is on ground is our Boolean. So now all we have to do is throw in this jump conditional, if is on the ground, and you just press the space key, then allow jumping. So if I run it now that we have this check for the ground, let me try to double jump here. I can't. So it's working, right? So we jump, and you can actually see the ray being casted on our debug drawer. I just press F1 to turn that on. And you can see that purple line right below. That's our ray cast being drawn. And it's not hitting the ground. It looks a little weird from this angle because of the camera controller, unfortunately. But that's what we're doing. And I can no longer double jump because no ground is detected when I try to do that. So the last thing we're going to look at is handling slopes. And let's just take a look at what the current behavior is on a slope, and you'll see what the issue is here. And this is an issue that happens all the time with dynamic character controllers. Very common issue. A lot of people have struggled to resolve it on Bullet. There's kind of workarounds. I haven't found an amazing fix. There's different hacky workarounds, and we're going to do one of those today. But you'll see when I try to go up this slope, the character I can't go up the slope. He's not moving. I'm pressing the forward button, and I'm just not able to go up the slope. If I let go of the forward button, I actually start sliding down the slope because, it's a slope and I'm rolling down it essentially, especially because the shape is a capsule shape, so that doesn't help. Now, how do we solve this issue with rolling down the slope? And I said many people try different solutions. we're going to try today a kind of like a, I hate to say it's kind of a hacky workaround, but with dynamic character controllers, you kind of have to be creative and come up with ways to work around some of these challenges. And it's usually not perfect, but let's just give it a shot. And so what we're going to do is in our dynamic character controller, where we did that is grounded check. Let's go right below that. And I'm just going to put a quick description here. Kind of a slightly hacky workaround to allow climbing up and preventing sliding down slopes. And the general idea is if we are on the ground, then we're going to check if we're going to check the normal, and let's just start implementing it. And I'll try to talk through it as we go. So if we're on the ground, that callback object that we have from the raycast, if it hits something, which if we are on the ground right here, then that means it hit something, because this is if there was a hit or not. So if we have a hit, if we're on the ground, then the callback should have a hit. And so in that case, we have this method get hit normal world. And this is going to give us the normal vector of the surface that the raycast intersected. And in this case, or most of the time, that's going to be the ground. So it's going to give us the normal value, the world normal of the surface of the ground where we are standing in our current spot. And if you don't know what normals are, you can look them up. I'm not going to really go into that today. There's plenty of stuff out there. There's YouTube videos, articles explaining what normals are. They're not a libGDX thing at all. They're a 3D modeling thing. So, look that up. If you have questions, you can reach out in Discord, but I think the internet, you'll find articles that can explain it far better than I ever could. So we're going to get this normal value from our whatever we hit, which is probably going to be the ground. And if you saw, I created a new vector 3 here, normal, to hold that value. So we're going to call get hit normal world. And we're going to get this dot product of the normal value. So we're going to go normal dot vector 3y. So we're going to get the dot product of the normal in our y vector. And the reason why is we want to see if the ground is flat. What I'm trying to do here is check, are we on flat ground or not? Now, and let me bring a comment over here to help explain this. If the dot product that is returned is 1 from this, so if we do the normal dot vector 3y, if it's 1, then that means that these are in the same direction. The normal and the vector 3y, they're in the same direction, which would mean that they're pointing straight up. So if we get 1 return, the ground is completely flat at the point that we're standing because it's pointing straight up with the y vector. The normal is. If we get anything else, pretty much other than that, if it's -1, then that means it's in the opposite direction. If it's 0, if we get a 0 value returned from this dot product, then that would mean that the vector 3's, they're perpendicular to each other. So in this case, what we're going to do is check if the dot product is not equal to 1. And here's the hacky kind of workaround part here. So if we're on a slope, what we're going to do is, right, because if it's not 1, then the ground is sloped in some way or the other. So if the ground is sloped, we're going to go body dot set gravity to 0. So we're actually going to disable gravity on our rigid body if it's on the ground and it's standing on a slope. And that is, it's like I said, it's kind of a hacky workaround to allow us to get up these ramps by just disabling gravity when we're on a sloped terrain. Else, we want to make sure that the gravity is then set back. If we are not on the ground, say we jumped, we need to add that gravity back to the body. Otherwise, we're just going to float there. So otherwise, we need to set gravity, and we're going to want a constant value for our gravity. So let's head over to our bullet physics system. And at the top here, yeah, so I'm going to bring over this, and I believe this is pretty much the same default value that bullet uses. So you can see that the value of the gravity is on the y axis, and it's just negative 9.81. And from what I understand, that's the default gravity that bullet uses. So now we go back to our character controller, and if we're not on the ground anymore, we need to set that gravity. So we'll go bullet, physics, system, set gravity to the default gravity. And so now what we do is essentially we're checking, get the normal vector of the ground right below the player, check if it's sloped or not. If it is not, or if it is sloped, which means it's not equal to 1.0, then we set the gravity to 0 on the body. This is not a perfect solution, but it is one way to try and handle slopes. So now let's go ahead and try to walk up that slope, see if we can. And I think probably more tweaking is needed on this. I think I had some issues here with this ledge because there's still a little bit of a bump there. So if I jump up here, we can now climb up the slope. And with dynamic controllers, you could try to work out that bump by doing a raycast in front of the character if you want. I'm not going to go to that level here. But let's also try standing still and see if we're sliding down. And you can see we're not sliding down because we've disabled the gravity while we're on a slope. So there's no forces pulling the body down. If you need to, with dynamic character controllers, often the recommendation I see on the bullet forums and things like that is to, design your levels around the controller as much as you can. So little bumps like this or little staircases, you might want to make them smooth ramps instead, because if we go here as well, you'll notice, these are some of the drawbacks of the character controller. You can try to keep adding on to it if you want to handle stairs. Generally, I'd recommend, use a kinematic controller if you can, and I'll try to do a video on that next. Unless it's like a bullet or a ship or something like that, then this works great. Or not a bullet, but, unless it's a boat or a ship, then it'll work great. But I think I'm going to end it here. Like I said, it's kind of a basic character controller. I hope it's helpful to at least get you started if this is the route you want to go. And let me know if this video was helpful.